This is the first section of chapter 10, and we are graphing quadratic functions. So we have lots of new vocabulary in this section. The first thing we have is the parent quadratic function, which is just the function y equals x squared. So that's the very basic quadratic function that we talk about when we think of a quadratic function. And that's what we're going to compare everything else to. So quadratic functions are all parabolas, which is the U-shaped graph. Looks like this. The vertex is the lowest or highest point on a parabola. So down here, this would be the vertex. If it was negative and it looks something like this, the vertex would be up here at the maximum. And then the axis of symmetry is the line that you can draw down the middle that divides it into two symmetric parts. So that makes it like a mirror image on both sides. Okay, so to graph a quadratic function, we can use a table of values, just like we did with linear functions. So the sort of most common ones to do, especially with something more basic, it's like the main 5 points that you'll see people choose. And then we're just going to plug them in for x to get our y. So negative 2 squared is 4 times 3 is 12. Negative 1 squared is 1 times 3 is 3. 0, 0. 1 squared times 3 is 3. And 2 squared is 4 times 3 is 12. So on here, I only go up to 10. So let's see, I get 0, 0. At 1, positive 3. Okay, at negative 1, positive 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So at negative 2 and positive 2, I'm all the way up at 12. Okay, and that gives us enough points to then draw our parabola. So again, it's a little tricky to draw, but it's just a U-shaped curve. And so that's totally doable, but our calculator will also do this for us. So we go type it into the y equals. But that's how you would do it by hand. So just to show you, in the red is what we just graphed, which was y equals 3x squared. And in the blue is the parent function that we talked about, y equals x squared. So that's the very basic one. And as you can see, the 3x squared got skinnier. So that number next to it made it a skinnier graph. Now, if we have y equals negative 1/4 x squared, you'll notice that a few things happen. First of all, it flipped the other direction, and that's because of the negative. So anytime you have a negative, it's definitely going to be facing down. And then the fraction versus the whole number, the 3 from before, made it wider than the original parent function. So wider and flipped would be the comparison there. This one, you'll see we have y equals x squared plus 5, so that plus 5 over here actually shifted the graph up the y-axis. So the parent function was down here, and it just shifted up 5 units. So it didn't get wider, it didn't get skinnier, it just moved up because of that plus 5. So as you can imagine, if we have minus a number, that's going to move it down the y-axis. Okay, so to summarize, if we have y equals ax squared where a is greater than 0, it's going to make our graph skinnier when a is greater than 1. So when it's a whole number, that's when it's going to get skinnier. When it's a fraction, or in other words, it's greater than 0 but less than 1, that's where it's going to get wider. Okay, when A is less than 0, meaning it's negative, that's when it's going to flip over the x-axis and be facing downward. And then C is what's going to shift it up and down. So plus C is going to move it up the y-axis, and minus C, or a C less than 0, is going to move it down the y-axis. So here you're just thinking up, down. Here you're thinking flip. And here, greater than 1, you're thinking skinnier and wider. Some people will get confused by the idea of stretch and shrink. Technically, when they say stretch, they're talking about the skinnier one, because it's like you're pulling it upwards, and shrink is like you're pushing it down. So shrink is talking about the wider one. I prefer to say skinnier and wider because I think it is less confusing. Okay, so for example, how would the graph of the function y equals x squared plus 3 be affected if the function were changed to y equals x squared plus 9? So remember, plus 3 would move it up the y-axis by 3 units, so plus 9 would move it up 6 more units. So the graph would shift 6 units up. Okay, so we talked about the axis of symmetry, but there's actually a formula that you can use to find it, and that's negative b over 2a. And the axis of symmetry, since it goes right through the vertex, also tells us the x-coordinate of the vertex. And then the y-intercept is always the c, so it's always plus whatever that number is, tells us where it crosses the y-axis. Okay, so for example, if we're given this quadratic function, we can find the axis of symmetry and the vertex. Remember, negative b over 2a. This is ax squared plus bx plus c. So that means I'm going to take negative 12 over 2 times negative 2. Negative 12 over negative 4 is positive 3. So the axis of symmetry is at 3 on the x-axis. And then to find the vertex, I now only know the x-coordinate, so I can find the y-coordinate by plugging this back in. 3 squared is 9 times negative 2 is negative 18. 3 times 12 is 36, so negative 18 plus 36 is positive 18. Minus 7 would be positive 11. So that's how we could find the axis of symmetry and the vertex algebraically. And the only other new vocab for this section, we have maximum and minimum values. So if you have a quadratic function, it's either going to have a minimum or a maximum. So if it's facing upwards, meaning it's positive, it has a minimum value. The vertex is at the very lowest point of the parabola. So the minimum is also the vertex, or the maximum can be the vertex. Okay, and that happens when we have a negative function. So if you know whether your function has a minimum or maximum value, we can also find the vertex on the calculator because it will calculate the minimum or maximum value. Given the quadratic function y equals 3x squared minus 6x plus 2, does it have a maximum or minimum value? Well, remember, it's positive, so that means whatever it looks like, it's going to be facing upward, which means it has to have a minimum value for the vertex. Alright, and for our last example, which function has the graph shown? So notice that this parabola is facing down, so it has to be a negative quadratic function, so it can't be C or D right off the bat. And then, well, this tells us that the y-intercept at 3, but they both have a y-intercept of 3. So then I sort of just have to figure out which one has a vertex of 2, 5. Also, remember that stands for x and y. So if we're talking test-taking strategy, really you can just plug in 2 and 5 for x and y and see which one makes it true. So if I do that for both, Okay, so if I plug both of those in, it only makes B true, because down here we end up with a statement for A that's not true. I also could find the vertex and the axis of symmetry by doing negative B over 2A. So if I do that, I get negative 2 over 2 times negative 1/2, which is negative 2 over negative 1, which is 2. So that is the axis of symmetry for letter B. And that's it for this section.